Hello everybody, and welcome to the first video in our series on yields. So yields is talking about what do we have left after we do something to a product. For example, if we buy a bag of carrots and it's 10 pounds, well, we have to trim those carrots, we have to peel them, and then we have to make them into diced or turned or whatever we're doing. A certain amount of that 10 pounds of carrots that we first bought is going to go in the garbage, right? It's going to be waste. So that's going to affect how we calculate the price of those carrots. Now, for the price of the carrots, I'm actually going to show you how to do the calculation in the next video. But for today, we're going to figure out what yields are, get used to the terminology, and figure out what percentage do we have left after we process, and how we can use that that percentage. So the first question I ask is, if you're having a dinner party for 8 people and the dinner party is having an onion tart and the recipe asks for 4 ounces of caramelized onions per person, and we need to figure out, well, how many onions do we have to buy? Now we simply can't go 8 times 4 is 32 and figure out that we need 2 pounds of onions, because if we went out to the store and bought 2 pounds of onions, we've got raw onions. Well, in order to cook those down into caramelized onions, we're not going to be left with 2 pounds, right? 2 pounds is the end result we need of caramelized onions. If we were to cook down those 2 pounds, we're probably going to be left with maybe 4 ounces, right? So this is where yields comes into play, and we can figure out what's our yield off of onions to get caramelized onions, and then we can use that to back figure out how many onions we need to order. So 2 pounds isn't the right answer, because you guys have all caramelized onions for French onion soup and veg, I would imagine by now. A lot of onions turns into a very little onions, right? So I'm going to show you how we figure this out. So some terminology to start with. Our first one, as purchased, or our AP, which is the form that we bought something. So in the case of the carrot example, I said it's 10 pounds of carrots in the bag and we paid, $5 for it or whatever. But that's the as purchased form, how we bought it. Did it come as a case of cauliflower that was 10 pounds? Okay, we bought 10 pounds as purchased. Our edible portion is the product after we've been prepped. So sometimes it's been cooked, like the caramelized onions, and the actual weight will reduce because of the moisture loss. Maybe it's just peeling and trimming, like turning carrots. You're going to end up with a lot less and a lot of wasted product, right? The yield is the measure of the volume of that product that's left over, right? So if we had 10-pound bag of carrots, we peeled, diced them, and we ended up with 8 pounds, well, that's what we have left with. The yield percentage is now that ratio between our edible portion amount and our as purchased amount. So what's our score out of our as purchased? We bought 10 pounds. We are left with 8 pounds after we processed them. So we have an 80% yield, right? So to calculate that, we're going to weigh our raw produce in its as purchased form. And then we're going to process the product as we would in a recipe. So if we're caramelize the onions, we're going to caramelize the onions, right? And then we're going to weigh what we have left so that we know what's the weight we got out of our purchasing. And then we can figure out the percentage by dividing our edible portion by our as purchased portion. And that'll give us a percentage that we can then use to figure out how much product we need to order, or how much product we can expect to have after we're processing whatever we have in our cooler. So as an example here, we've got a process. You process 17 pounds of cauliflower and get 10 pounds of florets. What's our yield percentage? So the first thing I like to do in questions like this is identify what the numbers mean. So this 17 pounds, what is that? Is that an EP or an AP? So we're processing 17 pounds of cauliflower, so that tells me that that is AP. So I like to label them. And then we get 10 pounds of florets. Well, florets are a processed product, so that's EP, right? So in order to calculate, we've got 10 out of 17, which is going to give us a yield of, click ahead in my notes here, do my percentage, and it's going to be, if my pen will work, 0.5, come on, And they give me computers that work so well. 0.588 or 58.8%, right? We take that 0.588 and multiply times 100 to get a percentage. So that's how we can visualize that we had end up with 58.8%. Out of that case of cauliflower that was 17 pounds, we only had a yield of 58.8%. So what if we did this backwards, right? What if we mixed this up and we did 17 divided by 10? We're going to end up with 1.7. If we multiply that times 100, that's 170%. How can we end up with 170% of 17 pounds? This should be a big red flag for you and say, hey, wait a second. If I started with 17 pounds, and if I got 17 pounds, that would have been 100%. So how would I get more than I started with? You're looking like a magician, right? How can you end up with 70% more than what you started with? So this is wrong. This, if you do the calculation backwards, should be a red flag and say, how did I end up with more than 100%? You know what? I probably flipped my numbers, right? So, and this is where I'm going to keep emphasizing as we go through this whole course. The numbers that you calculate, you have to look at them logically and ask yourself, does that make sense? Am I going to end up with more cauliflower than I started with after I cut it into florets? There's no way, right? Okay, next example I've got is another variation off of our edible portion, our EP and AP. So if we process 8 pounds of celery and are left with 7 pounds or 6 pounds 7 ounces for crudité, what is our yield? So first thing I like to do, like I said, is identify these numbers. So what have I got? I've got 8 pounds. You process 8 pounds of celery. So that's telling me that it's as purchased. And we're left with 6 pounds 7 ounces. So we're left with our EP, right? So we have EP divided by AP is going to give us our yield percentage, right? Now, the problem here is with this 6 pounds 7 ounces, we have mixed units. So we need to change that into a whole number. Well, how do we do that? If we remember from our unit conversion, we can take that's going to be 6 point something, right? So we're left with 7 out of 16 ounces in a pound. If we divide 7 by 16, we're going to end up with 0.4375. Our AP was a whole number of 8, so we can just divide that out and end up with a yield percentage of, I click my buttons here, 0.805 or 80.5%, right? So we know that if we process our celery, whether it's 8 pounds or 200 pounds, we're going to end up with 80.5% of whatever we started with, right? Because basically just over 19.5% is going in the garbage, right? We have 100% minus 80.5% equals 19.5%, which is, that's our loss. So that's what went in the garbage. So we can assume that anytime we process celery, we're going to lose 19.5%. Okay? So a couple of notes on produce. The yield percentage changes with the type of processing, even on the same vegetable or fruit. Think about back to soup and veg and you had to turn carrots. And I know you all hated doing it because it's very frustrating and getting them all identical and perfect. But there's a lot more waste of the carrot when you're turning them versus when you're doing a small dice, right? So your yield percentage is going to change depending on how you process that yield, right? The formula assumes that the trim's not used elsewhere. Otherwise, your yield percentage is higher if the waste is put to use, right? So if your trimmings are going in your stock, then it's not a complete waste. You're substituting out. However, personally, I don't put trimming and peels in my stock. That's garbage to me. I'll put good usable trim in my stock, but I'm not going to put dirty carrot peels in my stock. Garbage in, garbage out, right? So our yield percentage should remain consistent for similarly trained employees across the days. So if you have some employee that's really good at turning carrots, they're probably going to have a better yield percentage than an apprentice just starting out. But your yield percentage should be based on the similar level that everybody else would have, right? If there's a item that is portioned by count, the yield percentage is 100%, even if you don't use the whole thing. And what I'm talking about here is, say you have a recipe for apple pie, and it calls for 10 apples. You're not going to use the core, and you're going to peel those apples, right? But the recipe is assuming that you're going to peel and core those. They're thinking, this guy's not stupid, he's not going to put the core in the pie, right? So even though your apples, if you were to buy 10 pounds of apples and peel them and core them, you're probably only left with 6.5 pounds. The yield percentage doesn't matter because the recipe is already assuming you're going to do that. You're not going to have to buy more apples to make up those 10 apples worth of core that you've pulled out. Now, if the recipe said that you need 4 pounds of apples in that recipe, then you're going to have a yield percentage for those apples, so to make sure that you have 4 pounds of usable peeled cored apple to go into that pie. But if the recipe calls for 8 individual apples, you don't have to worry about it because the recipe is assuming that you're going to peel and core them, right? Any items that are bought in a size range, you assume the worst case scenario with the lowest value. So what am I talking about here? Things like shrimp, where you have a 21.25, right? If you're calculating your yield for that, you're going to assume worst case scenario that you're only going to get 21 shrimp out of that pound, right? Because 21.25 means you're going to get shrimp that are in the size such that every pound you're going to have between 21 shrimp and 25 shrimp, if you remember back from range. So when you're costing your recipe, you're going to assume worst case scenario. You're going to assume you're only getting 21 shrimp out of that pound, okay? So all of this rolls into a nice little triangle that we can use. We have EP on the top, AP on the bottom, just like we did in our last 2 examples, and our yield percentage on the bottom. So if you remember your math from high school, this is sort of a simplification of cross multiplication. So if you remember your EP over AP and your yield percentages of multiplication on the bottom, you can now use this triangle to determine any one of these missing items. So if you have, 10 pounds of carrots in your cooler and you know you're going to have an 80% yield, you can use that to figure out that what you can expect to have once you've peeled and trimmed and diced them, right? If you know you need a certain amount of carrots to serve a certain number of customers, you can use that yield percentage now to figure out how much you need to order, or your AP amount, right? So I'll illustrate that in a couple of examples that are coming up, right? So first example I have here is how many ounces of broccoli florets can you get from 10 pounds of broccoli if the yield for florets is 68%. So again, like any question, I want to identify what the numbers that are in my question. So right off the bat, 10 pounds. Is this edible portion or is this as purchased? How many ounces of broccoli florets can you get from 10 pounds? So that tells me that's AP. Well, and then it tells me right here that this is a yield percentage, so I know that's a yield, right? So we have our nice triangle. EP over AP times yield percentage. Now we can take our AP, plug that in down here, 10 pounds, and our yield percentage. Now the trick here is recognize you need to turn this back into a decimal. You cannot do the calculation with it as a percentage. You need to turn it back into the decimal version. So 68% is now 0.68. Well, if I follow my triangle, 10 pounds times 0.68, I'm going to end up with 10 times 0.68, which gives me 6.8 pounds. And if I want to turn that into ounces, because the question is asking me for ounces, I need to multiply that times 16 ounces in a pound, which is going to give me 108.8 ounces, right? So now I know that if I had 10 pounds of broccoli in my cooler, and we're going to turn that into florets, I'm going to end up with 108.8 ounces, right? So I have a reasonable expectation of how much I'm going to have that I can use for making my broccoli soup or making whatever. Do I need to order more or not? Right? So the next example I have is, how many pounds of jicama should you purchase to get 4 pounds of julienne jicama if the yield percentage for julienne jicama is 88%? So again, this is a great example of how we can use the percentage to determine how much we need to order or have on hand, right? So again, first thing I want to do is identify what I've got. So I've got our yield percentage. That's a pretty easy one to figure out, right? It tells us. Now this 4 pounds, is that EP or AP? And we have to read the question carefully. How many pounds of jicama should you purchase to get 4 pounds of julienne jicama? So we want 4 pounds of julienne jicama. Julienne means we process it, we've cut it in our little matchsticks, so that tells me it's EP, right? Back to our triangle, we've got EP over AP times yield percentage. So I'm going to take my yield percentage, put it down here as a decimal right away. My EP is 4 pounds, so now I need to do 4 divided by 0.88, which is going to give me 4, my pen works, 4.55 pounds. Now, if I'm going to order this from a grocery store or a supplier, I probably can't order 0.55 pounds, so I'm going to have to order 5 pounds and round it up, right? So this is an example of something I used a ton in my career. Knowing how much of a product I needed to serve my guests would help me determine how much to order. It wasn't just a guess so I would end up with too little or too much. It was an actual mathematical equation that I could figure out how much I had so I had enough to serve my customers, but not have a bunch that's going to sit in my cooler and go bad. Now, again, like I mentioned before, we need to sort of logically fact check this answer. We got 5 pounds. We need 4 pounds, right? So if we take 5 pounds and process it to get to that 4 pounds, that makes sense, right? Now, if we did this math backwards, or we mixed up the EP and AP, and we did 4 times 0.88, we're going to end up with less than our 4 pounds that we needed. And there's no way that we're going to be able to get 4 pounds if we started with 3 point something, right? So this is where you have to not just trust that you're punching things into the calculator properly. You need to look at your answer and say, does that make sense? If I went to the store and bought 5 pounds of jicama, can I turn it into 4 pounds of julienne jicama? Absolutely, right? That makes sense. Next example I have here is a chef serves a 3-ounce portion of sliced beets per customer, and she has 12 pounds of sliced beets, or 12 pounds of as-purchased beets in the Walkman, and the yield percentage for the sliced beets is 90%. How many guests can she serve? Okay, so this is a little bit more complicated, but it is a real world situation, right? So first off, this 3 ounces, is that EP or AP? Well, we're serving it to our customers, and it's sliced, so I would say that's EP, right? Next number we've got in here, we have 12 pounds of AP. Well, that was nice of her to actually tell us that it is AP, right? And our yield percentage is 90%. All right, so how many guests can we serve? Well, if we're going to serve each guest 3 ounces and we have 12 pounds of AP in our cooler, we need to figure out, once we process that 12 pounds, how many pounds am I going to have left once I process it? So our triangle, EP over AP times yield percentage, and we're going to take our 12 pounds of AP and our yield of 90%. We can multiply that out and get, oops, my calculator, 12 times 0.9. We're going to end up with 10.8 pounds, right? Now, we need to figure out how many 3-ounce portions we can do. So we need to turn this 10.8 pounds into ounces by multiplying times 16, and we're going to end up with 172.8 ounces. Now, if we're going to serve each customer 3 ounces each, we're going to now divide this by 3 to get 57.8 0.6. So how many customers can we serve? 57. We cannot serve 58, even though rounding rules would say we would round up to 58, but we don't have enough physical beets to make that whole extra portion. So if we were going to serve 58 people, we would be cheaping out on somebody. Somebody's only getting a couple ounces of sliced beets instead of the full 3-ounce portions. So really we can only serve 57 customers, and then we're going to have 0.6 of a portion left over, right? Okay, so this is yield percentage. This is how we can figure out the physical amounts we need to order, or figure out how much we're going to have left of a product without actually doing the work. We've done an example of the work to figure out what our yield percentage is, and there are plenty of locations. I have a link or an actual file on Moodle in the resources section that gives you a whole base of what the yield percentages should be for if you're dicing carrots or you're julienning carrots or whatnot. Now, this is going to be a little bit different from place to place and skill level to skill level, but it should be pretty close, right? So once you've got that yield percentage, you don't have to physically peel all your carrots and chop them up to figure out how much you're going to have left with. You can plan your order by saying, okay, we've got 10 pounds of carrots in the cooler. We're going to have 8 pounds after we process them. We need 15 pounds to serve our customers, so I know how much to order, right? That's what this video has been all about. Just understanding as purchased, edible portion, and then how we get our yield percentage. In the next video, we'll talk about how this is going to affect the pricing for when you go to calculate your food cost or use say carrots in a recipe. All right, thank you. That's the end of this video, and we'll see you in the next one.